Welcome to Tuesday Lunch and Learn. I'm James Shore. Every week we choose a software engineering topic, come up with a challenge related to that topic, and then solve it live on stream. And this week it's international dates and time. If you'd like to follow along with me with the code on GitHub, go ahead and check it out here, github.com/jamesshore/livestream. Check out this tag, 2020-07-21. Your comments and questions, as always, very appreciated. Go ahead and toss them in the chat. I'll take some of them as we go, and there's also time at the end for more questions. So let's get right to it. International dates and times. Now, there's a lot of libraries to do international dates and times. So actually putting out international dates and times is not a big challenge. Of course, when we're talking about international dates and times, what we're talking about is putting out a time in the user's local language and also their local time zone. Those are the two major pieces that I can think of right now about internationalizing dates and times. It's pretty easy to do that. Like I said, there's lots of libraries to do that. The challenge isn't writing out the local time zone or language. The challenge is doing that in a way that's testable. Because of course, what we want to have happen is we want our programs to print out, we want the output to change according to the location of the user, but we want the tests to remain the same regardless of the location that the tests are run in. So how do we deal with that? And it's also really easy to forget because you're kind of in a bubble when you're writing time-based tests. You're in a particular time zone, that your team is typically in the same time zone as you. You're typically all speaking the same language. And so you write your tests and you run them, everything seems fine. And then another team in a different time zone, or perhaps speaking a different language or having their computers configured as a different default language, runs your tests and they fail. Or your CI server, your build server, which might be in a different time zone, it runs the tests and they fail. So it's easy to forget and then you get surprised later on, and that's really no fun. So today's challenge is to solve this problem. We're going to take the code that we built last week. And if you missed that, you can find all back episodes here, jamesshore.com/blog/lunchandlearn. What we did last week was we wrote a little countdown timer, printed out one line every second, and leading up to something. And what it was leading up to was printing out the current time in the current user's language and locale. So that's what we're going to add this week. We're going to take this countdown application that we built last week, we're going to add the ability, we're going to have it print out the local date and time at the end. Again, simple little problem. The challenge is making this testable so that the tests still pass regardless of where the tests are run and what language the computer that's running the test is configured to use. So how do you do that? Well, go ahead and ponder that for a moment. While you're thinking about that, I want to let you know that this show is made possible by the people who hire me to do training and consulting for them. A number of companies who want more business agility, actually have the capability for more business agility, bring me in because they have that capability for business agility, but not yet the engineering capacity that they want. So they bring me in for anything ranging from training on engineering, agile engineering skills, all the way up to process design and large-scale agility, how to have multiple teams work together. It's quite common for large teams to have trouble with coordinating across teams, and bottlenecks often form. Mistakes or cross-team communication is a common source of errors and mistakes. Anyway, if you'd like to join this group of well-educated, above-average people, go ahead and send me an email, jshore@jamesshore.com. You can also find out more about me on jamesshore.com. I also welcome tweets from anybody at James Shore on Twitter. In particular, I would love to hear from you about what you'd like to see us cover in future episodes of this show. I've been going on for, I don't know, maybe a couple of months now. I still have lots of ideas about things we can cover, but I would like to hear your ideas too. So go ahead and send me a tweet at James Shore on Twitter. What would you like us to cover here on Tuesday Lunch and Learn? All right, let's get back to today's episode. Today's challenge is international dates and times. What we want to do is print the local date and time in the local user's language and time zone, but we want our test to pass and work the same regardless of which time zone and language the computer is set to. How do we do that? Well, the key insight here, what sort of makes this all easy, the key insight to realize is that time zones and locales, the current time zone and the current locale, are external state. And like any other external state, we just need to wrap that up in an infrastructure wrapper. And once we have it wrapped up, then now we can control it. We can test it we can control it with mocks in our tests, or we can use nullable infrastructure wrappers. Either way, as soon as we wrap up that external state, we have the ability to put it under our control. So for today, what we're going to do is we're going to take our existing nullable infrastructure wrapper for our system clock, and we're going to extend that to work with the local time zone and locale. Now, if we had a more complicated application, we might actually make a dedicated wrapper just for the locale, for the time zone and language, or maybe even one for each. But that gets pretty complicated. We don't need that sort of extra complexity, so we're going to just keep it on our clock wrapper for now. So let's go ahead and get to the code. If you'd like to follow along the example, you can follow along in any language. However, I have an example already prepared for you written in node.js. Just download the source code. Again, that's available at github.com/jamesshore/livestream. Check out the tag 2020-07-21. At the end of today's episode, I'll have the finished results under the tag 2020-07-21-end. If you have, once you download the code, you'll need a copy of node.js installed. In particular, you need node.js 14 for today's episode. And the reason for that is that previous versions of node.js did not include support for locales other than US English. So if you want support for French or Kannada, or I don't know how to pronounce that, or Ukrainian, some of the things we're going to be using today, you're going to need node.js 14. Once you have that installed, though, you can run the build very easily. Just type /build.sh or just build on Windows. Press enter, and you're going to see that it will lint all the tests and lint all the code and run all the tests. If you want to have it only lint and test the things that have changed, use the quick option like this. And then if you'd like it to automatically run the tests when the build changes, when anything changes, use /watch or just watch on Windows like this. That will also make a nice little sound when the tests pass or fail. To run the code, use /run.sh or just run. And you can see what we have right now. We have this countdown where it prints out one line at a time. And what we want to do is right here at the end, right there, we want it to print out the local date and time. So that's what we're going to do. Let's go ahead and look at the code. Countdown is where the logic to do the countdown happens. You can see it's fairly simple. All the text is here in run.js. You're welcome to change that. Have fun with it. Do whatever you like there. The countdown, of course, is where the clock is going to go. But in order to support this, we are going to need to modify our clock infrastructure wrapper. And that is here in the unsurprisingly named infrastructure folder. You can see clock, test, and clock. And this is going to have everything we need this is where we're going to be modifying our clock to support local time zone and language. If you look at the clock test, you can see that it provides the current timestamp and it waits a certain number of milliseconds, and it also has support for nullability. The actual clock itself is fairly straightforward. We have some factory methods to construct it, and then the ability to give us the current time, advance the time if we're using our null clock, and wait a certain amount of time. And then we also have an embedded stub, which is how we actually implement the nullable infrastructure. And again, if you'd like to learn more about how this works, you can check out these episodes here, jamesshore.com/blog/lunchandlearn. You can find more about infrastructure wrappers in the episode titled Application Infrastructure. It's one of the earliest ones. And then a couple of episodes after that, we also have Testing Without Mocks, which is all about nullable infrastructure wrappers. And you, of course, can apply mocks to the same problem. And we have an episode on that called Mocks and Stubs. But let's go ahead and get back to today's challenge. So what we want to do is we want to have our clock have the ability to output the current time. And we want to do it using the current location and current time zone and locale. So let's go ahead and add a test for that. Let's say that it provides or outputs current time using current language and time zone. Or let's say computers, language, and time zone. So we'll need a clock. Let me go ahead and bring up our tests here. There we go. Okay, so we're going to need a clock, and we're going to need to have some way of getting the current time out of that. Let's just say clock.toFormatted_string. And to format it, we'll need some sort of format. And what I'm going to use is I'm going to use the default internationalization and localization built into JavaScript. Of course, there are many libraries to do this. One that's popular in JavaScript is called, I wanted to say Medium, but I don't think that is. Oh, it's Moment. It's called Moment. You could use that too, of course, but I'm just going to use the built-in logic. And that's why you need, if you're using Node.js, you need to use version 14 or better, because they did not have full support for date-time format in previous versions. They did support the API, but they didn't actually do anything different than the US. So anyway, what this allows us to do is this allows us to pass into locale and a bunch of options. And those options are things like what kind of date do we want? What kind of time do we want? Lots and lots of other stuff that we're not going to get into today. I think that for today's exercise, we just want to use those same options. It's probably the simplest thing to do here. So let's say that the date style is medium and the time style is medium. And we'll just pass that into our clock and see what comes out. We'll assert that that equals something. Now, if we do this, I expect this to fail because toFormatted_string is not a function, but that's easy to add. Now it should fail, saying that we got something we didn't expect, and now we can actually do it. The way you do this in JavaScript, and of course this is going to be different in different languages, is first you need a date. So I'll make a date that corresponds to now. And then you can ask that date to format itself by saying toLocale_string. The first parameter is a locale, which I'll put in as France, and then you can put in the format options. So if I do that, we should see something come out. There we go. 21 July, well, basically the French option. And if I do this as US English, we'll see it come out, yeah, July 21st, 2020. So that's working well. Now we just need to actually assert on this. And this is a bit tricky because we don't actually know what the current time zone and locale are. We don't even know what the current time is. So what we're going to have to do is we're going to have to just set our expectation to be basically duplicating the code. And I don't love this. Let's see. Let's go ahead and have this. We'll tell it to use the current locale. And we'll tell it to use the format we specified. And over here, we can say we want the current locale as well. And I don't love this because what we're doing is we're basically replicating our production code in our test code. And so I'd much rather have a hard-coded string that said exactly what we want. But in this case, I don't know how to do that because the date and time and locale are constantly changing. So there's no way to hard code this. So we're just going to have to do it this way. There we go. Now this, you might think this is enough, but it's actually not. Notice here that the time we're getting is 12:13 and 0 seconds. But what if there's a hiccup while this test is running? It could happen. Then the expected value will be 12:13 and 1 second, and our test will fail. One thing we can do about this is we can convert our time style to be short. And if I show you what this looks like, we're going to see that thanks for the comment, Doda. I'll get it to that in just a moment. What you're going to see here is that that brings us down to not having the seconds, but we're still going to have a little bit of a problem here, which is that it is possible for the actual value to happen right at the end of the current minute and the expected value to happen right at the beginning of the next minute. We, of course, could take out the time entirely and just show the date. But now we still have the problem. We've just made it less likely. Now the problem's going to occur right at the end, right before midnight and right after midnight. We don't want these sort of flaky tests. And I talked about this a lot in last week's episode, how we can avoid flaky tests. Yeah, Uncle Scientist says this problem sounds familiar. Yeah, we've still got this problem. Now, last time we said is at least, but this time we're dealing with strings, so we can't solve that. So here's what I'm going to do. We don't want flaky tests. So what we're going to do is we're going to take our expected value, we're going to calculate it before the actual value. And then we will check to see if the expected value equals the actual value. And if they don't, we will recompute the expected value. Like this. That way, if it happens when the minute rolls over, then we'll recalculate it. Now, that does mean if the test delays for a whole minute, we still have a problem. But honestly, that's not so much of a problem because our test will time out before that happens. If we really, really wanted to deal with it, we could take the time out entirely. And then our test would have to delay for a whole day before it was a problem. But yeah, and Lazy Dev says in the comments, it still feels dirty. It sure does. I so agree. And I wish there was a better way. Now, Dota2 Attitude, thanks for the comment, Dota. Dota says, could you DI the date object? Could you use dependency injection? You could, but then you're not dealing with the real date. And what I want to do is when I'm testing infrastructure, I do want to test that it works with the real thing. Because if we only use dependency injection, if we only introduce fake objects, then it's easy to get into the situation where we think we're using the API correctly, but we're not. But it is true that really what we're testing here is that we're testing the API, not the behavior. So what I'm going to do is I'm just going to check it manually. I can see from inspection that this is correct, and then I will lock it down using the test. But I expect that if somebody else comes along in this and changes this in the future, they will have to do the same sort of manual inspection. That said, Dodo, when we get to the nullable part, we are going to be using dependency injection of sorts on the data object, and that will give us an additional level of confidence. But in order to know that we're using the real API correctly, we really need to call the real API. So there we go. We are now outputting the current time using the computer's language and time zone. Now that is all we need for today's exercise, but in the interest of completeness and just showing you how this stuff works and what's going on with this, I also want to say that it can output the current time using a configured time zone. And again, we don't need this for today's exercise, so some people would say you aren't going to need it, don't program what you don't need. And I have a lot of sympathy for that. But I'm going to be a little bit more complete. Thanks, John CVV. You're absolutely right. I'll get to that in just a moment. I'm going to be a little bit more complete today and configure the time zone and the locale just so you can see it. John CVV caught an error though. This should be expected does not equal actual. Thank you so much for that. And that is the problem with this sort of race condition stuff is that you can sort of try to anticipate it, but you actually can't solve it completely until the race condition hits you. So when that happens, when you get those race conditions and you get a flaky test, don't just run the test again. I know it's so tempting. Don't just run the test again. Don't take a look at the test and fix the problem so they don't continue to fail. Because as I mentioned last week, when you have flaky tests that fail randomly, it's not a problem when you've got 100 tests. It's not even a huge problem when you have 1,000 tests. But when you have thousands of tests and half of them are failing randomly, even one failure in 1,000 means that you're going to be having a lot of aborted test runs. That's just not great. It's not fun. In fact, one thing I discovered between last episode and this one is that I had to bump this down a little bit because it was flaky on me. So hopefully I've solved that problem. I thought that the set timeout guaranteed at least the timeout, but I had it fail here. If you're wondering what that's about, go ahead and check out the last week episode from last week. That was called No More Flaky Clock Tests. And the date on that in the archive is, I believe, the 15th. Okay, so let's go ahead and output the current time using a configured time zone. We're going to say that, well, first we need a clock again. And the way you do this in Java is you just have your format have a specific time zone. which in this case I think we'll use Paris. And we'll use a time style of short just so we can see it. Actually, yeah, let's go with short again. And the date we don't care about because that's not going to be affected by the time zone so much. And we'll have to do this sort of thing again. Except now, that looks like it should all work the same. So let's just manually check it. Yeah, so there's our 9:20 p.m. That is the current time in Paris, France, as opposed to the local time here, which is, of course, 12:20 p.m. Now let's go one step further and configure the locale. The way we can do this is we can expect that the value is going to be, let's say, French. And here we're going to expect the value to be French. And we should see that come out as French, but it's not. It's still coming out as the local way of doing this. And to make this more obvious, let's put the date back in. And you can see that's in English, and not only that, it's the US style of English. So we've got PM instead of 24-hour time. So to change this, we're going to need to pass our locale through to our to-formatted string, which we can do like that. And you'll notice that I'm switching the order of the properties here. The real library, the built-in library, uses locale and then format. I'm saying format, then locale. And that's because sometimes we're going to want to use the locale, and to do that, you've got to pass in undefined first. I just think that's really ugly. So one of the advantages of using an infrastructure wrapper is you get to write the APIs to work the way you want them to work, rather than dealing with whatever you're given. And so you can make the APIs just a little bit more natural for your needs specifically. Okay, so that's going to fail because we are not actually getting that. Let's go ahead and have this fail properly. So we're expecting the French version of this, but we're getting the English version. But let's go ahead and just take the locale here and pass it through here. And there we go. Now, I don't love these tests. I mean, we've already talked about how they're not great tests because it's hard to say that they're really testing anything. But another thing I don't like about them is that there's a lot of duplication here. So let's go ahead and factor that out. I'm going to take this down here, factor out our locale string here. Oops, let's do all of those. And then we can take this and turn it into a method. And I'm going to call that check to formatted string. And that should have taken the locale, but it looks like I grabbed that by mistake. Okay, that should still work. It does. Let me move this to a more convenient location. And I should be able to do the same thing here. Let me factor out the locale here. Oops. And we'll move this up. Move this down. And then we should be able to use our helper method. There we go. And then here, we'll just do it the way it's meant to be used. Like that. Good. All right, I think that's pretty nice. So that is implementation of our to-formatted string. We now have the ability to write out a string in any format we want using whichever time zone and locale we want, or the local time zone and locale. We're not done yet, but this is a good spot to take a break, or take a breather. So I'm going to go ahead and check this in. We have added clock.toFormatted string. Okay, now we need to make this testable. How are we going to do that? Well, we've got the infrastructure wrapper. We have the ability to control to-formatted string, so now we just need to do that. One way to do it, of course, would be with mocks, but instead what I'm going to do here is I'm going to use our embedded stubs and the nullable infrastructure wrapper pattern that I've talked about in the past. And again, you can find those in the previous episodes. So the way that works is we have a embedded stub here that provides fake versions of all the globals that we're using. And this gets back to what Dota suggested, which is it's effectively injecting the date object. So let's go ahead and write a test for this. One thing about the nullable infrastructure pattern is that the nullable infrastructure is production code. It's written as part of our production code. This is a trade-off with mocks. With mocks, of course, when you do mocks, you do it all in your tests, but you end up doing it over and over again. With the nullable infrastructure, you do it once and then you have it usable. And they're also sociable tests, which means that you don't have the kinds of false failures you get with mocks, and you don't have to write additional integration tests. You just write your unit tests and everything works pretty much the first time. And again, you can check out the archive. The Testing Without Mocks episode has more details. So here in our nullable tests, we are going to say that it renders to formatted string. And I'll make a null. I'll set the current time, so we don't strictly have to do that. It defaults to 0, but by doing this explicitly, we're making it more obvious to the reader why this test is working. Then we're going to run toFormatted_string. And I'm going to pass in both the format and the locale on this. So let's go ahead and pass in French as our locale, and our format is going to be, I think, this one. And we'll assert. Now this is all deterministic, it's all controlled, so we can assert that this is something specific. We don't have to go through the shenanigans that we did before. Let's see, okay, so we're getting the right language, that's good, but what we're not getting is the right time. We want this to be timestamp 0, which is back in 1970. So we need the ability to control our now here. But this is actually pretty straightforward. We've already got this controlled. We're already injecting a date. So we can just use the date that we're injecting. There we go. And that looks correct. So I'm going to go ahead and copy this into our test. Now we need the ability to control the locale and the time zone. So let's say that it defaults the time zone to GMT. I think for the format we're going to want, I think it's just time zone. So we can say time style. Let's go with long because that will tell us the actual time zone. And then we can assert that I'll go with US here. What we should get out of this, I think, is 12 o'clock a.m. GMT or something like that. Let's see what we get. Okay, we're getting the local time zone, my time zone, which is Pacific time. So we need to control this. Now, to control this, we need some way of controlling how toLocale string works. And that's a bit tricky because we're using a third-party library. We're using Sinon's fake clock library to control the date. So we don't actually have the ability to override this. Now, Sinon might have the ability to override it. I'm not exactly sure. But this also is something similar that you'll see in your code. You don't always have the ability to control everything. Fortunately for us, we do have this is not the only way to get the international time zone or the localization. We can also use the international.datetime format constructor directly and then control that. So I think that's what I'm going to do. First, I'm going to go ahead and set this test aside so we can refactor with a green bar. And then I'm going to take this and I'm going to change it so that the formatting happens inside of international date time format, like this. And then we'll return the formatter.format now. There we go. So now, and then what I'm going to do is I'm going to make this so that it's one of our globals. So I'll say that our standard datetime format is international.datetime format. That's going to fail with our nulls. This needs to be this.globals. I think that will fail our nulls. Yeah, it does because it doesn't exist. And then down here in our embedded stub, we can also do a datetime format. And to start out with, I'll just default that to the real datetime format. There we go. Now we can bring our tests back in. We want this to default to our time zone to GMT. We're not doing that, but now that our formatting is done by datetime format and we have control over it, we can just make this into a method like this. That will take the locale and the options. We'll return datetime format with the locales and the options. That's not going to work yet. We're not defining the time zone. But now we can say that if options.timezone is equal to undefined, we'll set it to our default value. And that should pass the tests. Except it looks like it's UTC, not GMT. In fact, let's default the time zone to UTC, not GMT. That's a more modern way of doing it. There we go. This might look good, but your spidey sense should be tingling. There's actually a subtle little bug being introduced here. And that is, in JavaScript and in a lot of languages, objects are stored as references. So when I pass in options here, I'm not actually passing in the object's reference. I'm passing in, or I'm not actually passing the options object. I'm passing in a reference to the options object. So the reference is getting copied, but the actual object isn't. So when I change the time zone, when I set the time zone here on the options object, I'm actually setting the time zone on the original options objects that are being used back in our test. And that can be a source of subtle little bugs. So I want to test that and make sure that we don't do that. I'm going to say that the format should still equal timestyle.long, and that the toFormatted string should not modify original format object. And I believe we're going to see that it does. Yeah, it does. You can see we've added this time zone UTC to it. So what we need to do is, rather than modifying the object, we need to copy it. And the way we can do that in JavaScript is by doing this. This makes a copy, a shallow copy of the object, which I think will be good enough for us. And then we can override the time zone with UTC like this. The way JavaScript works is whatever comes second overrides whatever comes first. So this should still work. If I put time zone second, it wouldn't. But if I'm putting it first, if there is a time zone here in the options, it will override the default time zone we provide here. And that should now pass our tests. So there we go. So that's defaulting the time zone. Let's default the language as well. I'm going to default the locale to France. And the reason for that is simply that I want to see if this works. And right now, my default locale is US English. So by using French, I get to see if it's working or not. So I'll make a new clock. I'll use the date format so we can see the difference in language. And we're going to expect that when we do this, let's see, and I guess the time zone. You know what, let's just build this let's all build this all together. So we're going to have time zone of UTC and a language of French. There is a difference between language and locale. As I mentioned earlier, for example, in the UK and in the US, we both speak English, but there are some subtle differences, and one of them is the way times are rendered. In England, I believe they use 24-hour time. Here in the US, we use AM and PM. So that's why locales, it says locale and not language, because even if you have the same language, there can be differences between locales. So here, we'll make this timestamp like this, date and time. Take this out. What do we get out of that? So we'll do this. Actually, I'm not sure what's going to come out of here. But what I do want to know is that if we don't pass in the specific locale here, we should get something else back, something in French. Pellet says, yeah, it gets fun when you start getting strings that use commas instead of periods for decimal point. Yeah, internationalization, localization, it's a whole can of worms. There's numbers, there's dates, there's, of course, bidirectional text formatting. And there's also just the question of different ways of rendering things. You might be used to concatenating strings to say the current time is such and such. But in some languages, it's going to say time, the current time is. And so how do you concatenate your strings? There's a whole mess of stuff to deal with. Today, we're just dealing with dates and times. Nice and simple. So, right, we're still getting the English version out of this, but we want it to default to French. So we need to come back into here, and we'll say that if the locales is undefined, the locales equals France. And here we don't have to worry about the original value being overridden because locales is not an object. It is actually just a value. It's a primitive. So we're okay there. Okay, there we go. That is our default value in French and using UTC. Great. I'm going to go ahead and take this and I'll paste it into our expected value here. And I suppose we'll need to modify this as well. I thought about factoring this out so we don't have it duplicated, but this is such a small, simple test, I feel like that would be overkill. Okay, so there's our defaults. Now we need the ability to configure them. But this should be pretty easy now that we've got the rest of it in place. So we'll make a clock, have it default to beginning of the epoch, and then the local time zone, let's say, is New York, East Coast time in the US. And the format is not super important, but let's go with our long time style so we can see the time zone come out of it. And that should be, I'm not sure what that's going to be. It should say something EST, I think, though, or EDT. Of course, we're not getting that. So let's go ahead and modify this. We just need to take this and give us an actual locale that we pass in. All of our configuration parameters come in right here. So we can just default this to French here, or to France there, and then to that. And I believe that will work. Let's see. What did I do? Oh, I did the locale. I meant to do the time zone. I guess I'm jumping the gun a little bit. Let's just do both at the same time. Time zone equals UTC here. And then we'll use that here. There we go. That is definitely giving us the right time zone, but we haven't done the locale yet because we haven't configured it. So the locale we will configure as, let's say, Ukrainian. Okay, I expected that to work. Why did that not work? We're still getting... Oh, well, it may have worked. I just don't have the right time style to see it. Yes, there we go. That is working. We're expecting Ukrainian date and the East Coast time. So there we go. We'll just paste that in. And done. It's all working. So what we now have is we have the ability to give ourselves the formatted current time, and we can control the locale and time zone, which means that we've got everything we need to write our code. In our production code, we'll use the actual computer's locale and time zone, and in our tests, we'll use the time zone and locale that we configure. So let's go ahead and do that. Here is the code that does the countdown. The actual countdown is very simple. It loops through some text, writes one line at a time, and waits a second after each one. The tests aren't much more complicated. We hard code some text, and then we just see that we get it out. So we're just going to take our clock here, and we're going to configure a specific time, which I'll set to now. Let's configure a specific locale, which I think I'll use as Ukrainian, and a specific time zone, which I'll set for, again, America, New York. Now, I don't have to configure these. I could just use the defaults, but again, I think it's nice in your test, whenever you're asserting on something, to make it obvious where that value is coming from. So we've configured the local time zone and language and locale. We'll advance one more second, and then we'll expect that what we'll get out of this is, well, something that looks a lot like this, except with a new line at the end. And I think I don't want the time zone or the seconds. I'll do it like that. We need a semicolon on that. And that's failing because we're not outputting it. We're just still seeing the last line of our text, but outputting this should be pretty straightforward. We'll just come down here. We'll get the current time, which is going to be clock.toFormatted string with a medium date and a short time. And then we can write that out. And after I've done that right, it will work. And I did. So there we go. It's tested. It should now work, because the way this works is when you're using the nullable infrastructure in the sociable test, you're doing good test-driven development, generally works the first time. Almost every time. So let's see it. Hopefully demo gods are smiling on me and it actually does work. There we have our quite overblown and overdramatic countdown, followed by current date and time, formatted for my time zone and my language. And that's how you deal with international dates and times. The secret here is to remember that locale and time zone is really just another type of external state, and it can be managed like any other external state. Treat it as infrastructure, isolate it with an infrastructure wrapper, and then control it in your tests using mocks or nulls. We have time for additional questions if there are any. I see that there is one. Thank you for that, Uncle Scientist. Before I take that, though, I have a couple of announcements. First off, our next episode is next Tuesday at noon Pacific, same as usual. That is going to be the 28th of July. And the topic is going to be idiot-proofing your code. And I'm talking about, well, me as the idiot here. Should be a fun episode. Don't miss that. Again, that is noon Pacific on July 28th. I also want to invite you to tweet me your suggestions for upcoming episodes. I do have a backlog of ideas, but it's starting to run low, so I'd love to hear what you'd like to hear about. Go ahead and send me a tweet. There it is, James Shore, at James Shore on Twitter. I'd love to hear what you think. And then finally, if you liked what you saw today and you'd like me to bring this sort of training to your team or other sorts of Agile consulting, go ahead and send me an email, jshore@jamesshore.com. When I do this sort of training, or really any sort of consulting, it's about using your language, your frameworks, often even your code base. I work in front-end and back-end JavaScript, Node.js and front-end JavaScript. and also Java and .NET. So if you'd like that, I'd love to hear from you. Again, jamesshore.com, happy to set up a free consultation. All right, let's take questions. Additional questions are very welcome. Uncle Scientist says, can you set locale on the command line environment variable and see the output change? I don't know. Let's go ahead and try that. If we do, let's say, let's do Kannada. Kannada? I don't know how it's pronounced. Sorry for all of you in Bangalore. Let's do Kannada as our language. Let's see. Let's do this right. And let's do our time zone as being our Indian time zone. And let's see what comes out with that. Now, this is why I like having the test and having everything under control, because having to wait 10 seconds every time to see this come out, not a lot of fun. Well, the time zone changed, but the locale didn't. Oh, sorry about that. Thanks, Lazy Dev and Uncle Scientist. So I set the locale and I set the time zone, and it went through and did all of that stuff, but the time zone worked, but the locale didn't. I actually don't know how to set the locale in Unix, and I kind of know how to do it in Mac, but I don't want to mess with it because this is my regular work computer. But I have done other tests in my Herschel, and I am pretty confident that it works. All right, doesn't look like there's any other questions, and this is a good time to stop. So that is it for today. Thanks very much for watching, everybody. Again, next episode, July 28th. It's about idiot-proofing your code. That is going to be at noon Pacific next Tuesday. Thanks again, everybody. That is it for this time. I will see you all next time.